First off, I'm going to start with lists. So lists in Python are, kind of the workhorse basic data structure. So they are a mutable data structure, and what that means is, so once you've created your list, you can add to it, you can remove items from it, you can do whatever you want to the list. So it's not just static, it's not stuck in time. So as you get more data in, you can add to it or you can pull it out. And I just wanted to go over some basic operations that you can do with lists. So a list, you can just grab one element out of it. So I grab the toIndex element, which in this case is the third element, because lists are 0 index in Python. And so that will give us 3. So if I would just change this to 0, it will give us 1. And we can always also do the slicing mechanism. So I can say, oh, I want to grab 0 to 2 elements. I want to start at 0 and grab 2 elements of this list, and then it will give you the first 2 elements. So you could do 1. Actually, no, that's not what it does. It does 1 to 2. I always forget that. So if you want to grab 1 to index 3, there you go. You have those elements. You can also see if an item's in a list by just doing the in operation. And so if it's not in the list, it will return false. If it's in the list, it will return true. And then you can always do the dir operation to see. Dir operation basically gives you all of the methods and properties on an object in Python, and everything's an object in Python. So it will show you all the methods and properties on a list. So you can see append, you can see clear, you got copy, count, extend, index, all these other methods, and they're pretty self-explanatory. As you can guess, reverse will reverse the list. Pop will pop an item off the list. Copy will copy the list. Count will give you the count on the list. So lists, they're pretty powerful within itself, and you can do a lot with them. But there's also some other data structures that, like tuples, for example, that you can use in place of a list sometimes. And an example of that is if you have some static data that you don't want to get changed. So let's say you have a few options, a list of options that you don't want it to change. That's immutable. Once you declare those items, it's like no other program can, or no other operation can change that that tuple. And so this is useful is if you have like some config or some static items or something that you want to keep static and nobody can change those at all throughout the program. And so you can do some of the same operations as you can do a list. You can see if the value's in a tuple, you can get an index of a tuple, but there's also a lot less operations because we can't mutate tuples like we can lists. So we can't add items to tuples, we can't reverse a tuple, we can't do anything like that. It's because they're immutable. And immutable means it cannot change. Once you declare it, you have to overwrite that variable to change that tuple. So you can overwrite the variable to a new tuple, but you can't actually mutate the tuple that you've declared. And so
is it just the list that's the tuple, or the elements in the list are also immutable?
The elements in the tuple are actually immutable as well. So you can't change anything about a tuple. So lists and tuples are pretty useful, but dictionaries are also really powerful. So dictionary, go ahead.
Can we ask questions right now?
Yeah.
So why would you use a tuple in place of a list? Seems like it would be more useful if you could change it.
So let's say you have a class and you are the programmer of that class, but you're going to hand it off to somebody else. Some other programmers can consume your class later on, and you have a list or a couple of items that you don't want changed. You're like, these items, I'm expecting them to stay this way, and so you can define a tuple, and so people will know not to mutate those items. Whereas if it was a list, some of the program would be like, oh, this is a list. I can just mutate this how I want it to. Whereas if it's a tuple, they can't mutate it. Or it also, it just keeps yourself safe from yourself. Like, you never know, you could write code, and then come back later, and it's like, oh, why did I make this tuple? Oh, I don't want it to be mutated.
So if you made a virtual coin, you'd put in heads and tails, and you'd never want to change that on a virtual coin at any point. So that would secure it that there's nothing that accidentally at the third side of your coin.
Yeah. So dictionaries are probably the most useful data structure in Python, I think. So dictionaries are key value pairs. So it has a key, and then it has values, which the values can be other dictionaries, they can be lists, and you can also have dictionaries inside a list. They can be interchanged that way. So you can have integers, like any values can be in dictionaries. And so this is powerful because you can use these to store properties about, say I have a bunch of names, and then I want to store data about those people, and then I want to look them up by their name. Dictionaries give you a really fast way to do that. So you can just say, I want to know the information about Colan, and then it will go and it will fetch all that information about Colan, and you have it right there. And so what makes dictionaries more powerful than lists, so let's say you had a list of items, and it was like, okay, I had the name, and then let's say I could still get the information. I could still loop over this list and find where that item exists. But where dictionaries are more powerful is dictionaries use something called a hash to go straight to that entry, that dictionary key. Versus lists, you have to iterate through the whole list and iterate through all the objects to actually find that value. So dictionaries, in some instances, can be way more efficient in terms of access than lists. Have you ever heard of big O notation? Big O notation is basically how the efficiency of an operation grows with the input of the size of the input to the problem. So accessing to find an item in a list is an order in problem. So you have to go through the whole list. Whereas a dictionary, to find if a key is in a dictionary, it's just O of 1. It's actually not true, but it is true for most purposes. You can always have hashing collisions and stuff like that, but that's kind of out of the scope of this. But for most good dictionary implementations, you can pretty much count on it being O of 1 of access. So you don't have to look through this whole dictionary. Let's say I had 10 million items in this dictionary. I could say, go to Colan, and it will go right there by the value. And so with dictionaries, you can get the keys, you can get the values, you can loop over the key value pairs of the dictionary, so then you can print out the key and value. You can see some of the operations on dictionary here. So we got, get. Get is basically, so with a get on a dictionary, you can do like I did up here, this operation, or you can do. But here, if it's not found, you can define something else. So if an operation's not found, or if the item's not found, you can return a default value to return to you instead of giving you an error. Whereas if you did this, you get a nasty error. So that's a syntax you'll see a lot because it's just safer. Instead of throwing an exception, you can kind of give it a default value that your program can handle. And then you see it has this dunder hash. So this is the dunder methods on all objects in Python have a dunder hash. So you can see this kind of gives you a clue of how the dictionary does the operations under the hood. It turns the string into an integer, and then you can use that integer to use an array under the hood. A dictionary is really just an array under the hood, but it uses the hashing mechanism to go to direct items in that array versus with strings versus having to loop through all the elements of an array. So this is basically treating it like an ordered array almost. Like if you knew you had 0 through 1,000, and you're like, I want 998, you can go to 998 in an array. But if you have a string, you don't know where, a string Colan, you don't know where that's going to be in an array. But hashing gives you a mechanism to compute and get that back. Any questions about that?
Does it hash every element?
Does it hash every element?
Like you just said, where that hashes what? The return for that single key, the single dictionary entry?
That hash is just the hash of a string. So it'll hash the key.
So every column, no matter what, will have that index, and that's how it
Yes.
does it.
So it uses a consistent hashing algorithm. So every string will have a single hash that's consistent.
So if you had a list of names like Bob, Mark, and Kayla, whatever, and say they just for simplicity purposes, Bob was 1, Kayla was 2, and whatever was 3.
Yeah.
When it got done hashing, that's how it orders it quickly. Is because it takes that first name, converts it to a number, and then it knows, okay, this number's here in the list.
Yes.
So that's how it finds it faster. Is it knows.
Yes. There's a little bit of more details of like bucketing depending on the underlying array, but that is exactly how it works. Yep. So I would say that lists, tuples, and dictionaries are the most common data structures in Python, but there's also the set. And sets, to me, they're kind of underused in my opinion. I've seen a lot of places where lists are used and where like a set would have made a lot more sense and it would make life a lot easier. So what sets are is, if you imagine a dictionary without the values, sets are just the key. So they're instead of a list where you have just the items stored in the list and they're indexed by 0, 1, 2, 3, 4, 5, sets are that, but they're indexed by their hash value. So it's like a dictionary's key without the value. And sets are, in the mathematical sense, equivalent to, the mathematical set and the Python set are equivalent. So you have like the mathematical set operations that you can do as well. So you can find like the intersection. So if you had to like arrays, if you want to find out the common elements in 2 arrays, you'd have to like write some code to do that. Whereas like the set in Python, you can just do intersection and you can return the common elements in them. Oh, one thing I forgot to mention is that sets are unique. So you see I have 1, 2, 3, 4, 5, 5. It gets rid of the second 5 because it's unique. All elements of a set are unique. So what can we do with sets? We can add an item, so they're mutable. You can do intersection. Go ahead.
What do they do with that other 5? I mean, if that was an extra name,
if there's 2 elements, it just uses it reduces it down to only contain that element one time. So you can do difference as well, another set operation, and you can see kind of some of the other operations here. You got symmetric difference, update, union, update. And update, I'm pretty sure is just like you can mass change. You can like pass in a bunch of keys and it will automatically change. I don't remember exactly what update does now. I'd have to look it up. But what else? Oh, a cool thing you can do with sets is if you have a list and you want to get all the unique items in the list, but you want to keep it a list for some reason, say you want to mutate it later again, you can cast it to a set and cast it back to a list, and that will dedupe all the items in the list. So that's a handy trick. It's probably not the most efficient way to do that, but it's definitely, it's efficient enough. I've never seen it be slow, and it's a handy little one-liner that you can do to get all the unique items in your array.
Are they ordered?
Are sets ordered? Sets are unordered.
As they're
Yep.
assigned?
Yep. I don't think you can even guarantee the order that they're put into the set either. I think it's just completely unordered.
It's not guaranteed what you put it in, the order you put it in isn't what you might get out.
I don't think it's guaranteed now.
So what's it like?
So basically, it's all you can really do with a set is you can say something's in it, something's not in it. Is that what you do with a set?
You can do something in, something's out, or you can do operations on other sets. Like you can do intersection or difference. But yeah.
Right. Okay.
So what's something where you'd use a set in as opposed to just a regular list? Other than just to condense.
here's a good use case where I think that a set is a better use than a list. Let's say you have a big collection that you have a bunch of items in it, and you want to tell, and it's not ordered, so you can't guarantee on an order, and it could change. So you could use a list for that. You could just have a huge list of, like, let's say names, a big list of names. Like you have 1 million names in there, and for a list. And you would have to go through, if you want to see if a name is in that list, you have to go through the whole list to make sure that that name is not in that list. Whereas a set just uses the one hash that we talked about earlier, goes directly there, and if that hash isn't there, it's like, no, this is not in there. So it's way more efficient than a list. Instead of having to go through all, 10,000 or, I don't even know, 100,000 or 1 million items, it will just, a set just can go directly to the spot and see if it's there or not.
So it's kind of like a dictionary, but without like the sub-elements to an element.
Duplicates, I guess.
Yeah, well, you can't have duplicate keys in dictionaries either. Yeah.
So if two people had the name Colin, you'd have to come up with like a Colin 2 or something then.
Yeah, if you wanted to store it.
I just did something like this at work this week, trying to figure out licenses across like 20 different systems. If you have this, you just pull all the user IDs, dedupe them, and there you go.
Yep.
I mean, it'd save a lot of money.
Yep.
A lot of money.
So here's a little timing that I did on sets versus lists. So the first one is, what is this? 100,000. And so to see if an item is in a set, it's, I don't even know what that unit of time is. It's small. But for a list, I mean, it's an order of magnitude higher to find if that same item is in the same list versus the set. And then we bump up the order of magnitude of the elements in the list versus the set, and we do some sort of timing there. And the set timing actually went down. It was actually faster, even though we had more. But you can see that to do it in the list, it actually increased by another order of magnitude. It went over another, I guess, I don't know what it's called, significant digit or scientific digit in scientific notation. So,
Decimal place.
decimal place, yeah, there you go. So you can see that is how, that's why lists are more efficient, or that's why sets are more efficient, is because it goes directly to it, where a list, it literally has to go through all of those items to make sure that it's in the list or not. So if I would just like to do the first item, which is here, I think it will be a lot faster. See, the list is, because it finds it immediately in the list. It goes, first element, oh, it's in there. Whereas when I had the last element, you can see the set time is not much different because it literally did the same operation. Whereas in the list, it has to go through that whole array and it finds it at the very last element. And it says, oh, it's in here. It takes a lot more time though. So the last data structure I want to go over, kind of running over a little bit here, I think, before I hand it over, is default dictionaries. And so these I find really useful. I didn't know they exist for a long time, but then I actually found out about it, and I was like, wow, that saves a lot of boilerplate code. So what this is let's say I'm doing the word count. Let's say I have a sentence and I tokenize all the words, and I have a list of words, and I want to count how many words are in here. So with a regular dictionary, I'm going to find a dictionary and see if the word's not in the dictionary, I can assign it to 1. I saw the word, so it's 1. And if it is in the dictionary, then I can do +1. And that's kind of annoying. Whereas default dictionary, you can say, okay, I want from collections import default dictionary. I can define it, and I can say, oh, this is going to be of type int. The values are going to be of type int. So I can loop over all the words, and I can say, oh, it's just +=1. So default dictionary knows, it's like, okay, it's an int, the default value for int is 0. So if he's doing +1, I'm going to add 1 to it. I'm going to add that element to the dictionary and then add it +1. So this can be useful in all kinds of cases to have to save you from doing if not in and then else and all that. And so there's also a whole collections library in the standard library that might have some stuff that saves you some time. Counters. I've never actually used counters. DQs, I've never used DQs. Default dictionaries, I've used those. Name tuples, I've used those. Those are kind of like tuples. They kind of function like a class without methods. I don't know how to explain it well, but you can have a tuple that looks like a class, but it's kind of lighter weight than a class. So you can give it properties basically. You can say, oh, this has an employee. This is an employee record tuple, and it has these properties. So
it's like a dictionary, but you can't change it.
It's more like a lighter weight version of a class, I would say. But I guess you could say that it's also like a dictionary, yeah. With the dictionary, the tuples actually has a name, like a class. So. Any questions? Cool, thank you, and I will hand it over to Kurt.